بسم الله الرحمن الرحيم. أحبائي طلبة الصف الرابع، نكون معاكم الجزء الثاني من الفصل السادس. Open your book on page 92 and write this question here. This is the question number 2 of chapter questions. What is the reason for brilliance of diamond? The answer is, start from here. Its critical angle is about 24.4 degrees. That is considered one of the most smallest critical angles relatively. So its absolute index of refraction is about 2.42, is relatively the greatest absolute index of refraction. The light falling on the diamond passes into it, suffer many internal reflections to comes out. This is the reason of this question. Example 3. If you knew that the critical angle of a light transmitted from transparent medium to air is 41.1 degrees, then what is the absolute index of refraction to this material? Noting that sine 41.1 is this number. Solution: we have the relation n equal the inverse of sine theta critical, n is equal 1 over sine 41.1 degrees, and the answer is 1.52. The reflecting prism. This is the reflecting prism used to change the path of the light beam by 90 degrees or 180 degrees. In this case, it's 90 degrees. This is the surface of reflection. The light incident from here and reflect here. In this situation, the reflection is 180 degrees. This is the first reflection, and this is the second reflection, and the rays come back. The periscope that is usually used in submarines to see the objects over the water surface. Here, write this question, why it is. Right? Why it is. Preferred use the reflecting prism in the optical devices rather than using plain mirrors. We use the prism rather than the mirror in these devices. The reason is because it is more reflector for light, and that's because light in the prism reflects a total internal reflection by approximate percentage to 100%, but in mirror absorption occurs. The fiber optics. Optical fibers are fine glass or plastic fibers used to transfer light from one place to another according to the phenomenon of total internal reflection. the angle of incidence on its inner cover is greater than the critical angle. It will get out of the other end even the optic fiber is curved. Optical fiber has a reflection index slightly less than the core of optic fiber. It's used in medicine, gastroscopy, stomach and kidneys, using a device called endoscope. Number 2, used in controlling internal material in medicine, used in controlling internal materials in machines and electronic devices, and also controlling nuclear reactors. Number 3, it is also used to transmit optical and audio information across the ocean and continents while they are loaded laser ray. The question of chapter 6. The first question, choose the correct answer of the following questions. Number 1. Which of the following statements express one of the reflection laws? C. An incidence angle equals to the reflection angle. Number 2. The speed of light in a glass is less than the speed of light in vacuum. The answer is A. Number 3. The ratio between sine incidence angle of incident ray in the first transparent medium and the sine of refraction angle in the second transparent medium is constant ratio for these two mediums. This is wrong word, it's media. The plural of medium is media, not mediums, and it's called relative index of refraction. Relative index of refraction, not refraction coefficient. Correct that also. Relative index of refraction between two transparent media. Number 4. The unit of absolute index of refraction for transparent medium is. The answer is D, has no unit. The second question, answer the following question. Number 1, what is the reason for brilliance of diamond? We just read it in page 92. Which one is more efficient in the light reflection, reflecting prism or plane mirror, and why? The answer is in page 93. Number 3. What are the two laws of refraction? What are the two laws of reflection? The answers are in page 83 and 85. Number 4. State the mathematical equation for Snell's law explaining the physical meaning of each symbol. The answer is at page 89. What do we mean by critical angle, and what is the relation to absolute index of refraction for transparent medium? The answer is critical angle, the angle of incidence at which the refracted angle makes an angle of 90 degrees with the normal. N equal to the inverse of sine theta critical. Number 6. What is meant by saying that the absolute index of refraction of water is 1.33? The answer is, it means the ratio of speed of light in the vacuum to the speed of light in the water is 1.33, which is constant, that is n equals c over v, where c is the speed of light in vacuum and v is the speed of light in water. Number 7. When the ray 1 is incident ray in the figure, this is the incident ray, then what are the reflected rays and refracted rays from other 4 red rays? Number 2, this is the ray number 2, reflected from 1, the reflected ray from 1. 3, this is 3, refracted from 1. Number 4, reflected from 3, reflected from 3. And finally, number 5, refracted from 4, refracted from 4. The problems of this chapter. First problem. If you knew that the absolute index of refraction of diamond is 2.42 and light speed in the vacuum is 3 times 10 to the 8th meter per second, find the light speed in the diamond. The solution starts with this equation, n equal c over v, so that v equal c over n, and it's equal 3 times 10 to the 8 over 2.42, and it's equal to 1.42 times 10 to the 8th meter per second. This is the speed in the diamond, speed of light in diamond. Problem 2. If you knew that the light speed in a transparent material is c over 1.52, where c is the light speed in vacuum, then what is the absolute index of refraction? N equals c over v, which is equal c over 1.52. Then we cancel c with c, and the answer is 1.52. Problem number 3. If the absolute index of refraction of water is 4 over 3, and the absolute index of refraction for a certain type of glass is 3 over 2, find the value of critical angle between these two media, not mediums, noting that sine 62.75 is this number. We solve this problem by using Snell's law, n1 sine theta 1 equal n2 sine theta 2. In this case, theta 1 is the critical angle and theta 2 is the right angle, 90. So that we substitute the values. 3 over 2 sine theta critical equal 4 over 3 times 1. Sine theta critical equals 0.889. Then theta c is 62.75 degrees. Problem number 4. A light fall from air on water surface at an incidence angle of 30 degrees. A part of it was reflected and another part was refracted. If we knew that the absolute index of refraction for water is 4 over 3. Find A. reflection angle, B. refraction angle, noting that sine 30 is 0.5 and sine 22.02 is 0.375. The solution of A to find the reflection angle. The incidence angle equals to the reflected angles and it's equal to 30 degrees. The solution of B, n1 sine theta 1 equals n2 sine theta 2, so that n1 is 1 times sine theta 1 is sine 30, n2 is 4 over 3 and sine theta 2 is unknown. Sine theta 2 is equal to 0.375, so that theta 2 is equal 22.02. Problem number 5. If the speed of light in ice was c over 1.31, where c is the speed of light in vacuum, find the critical angle for light transferred from ice to air, noting that sine 49.73 is 0.763. N equals C over V, and it's equal C over 1.31. We cancel C with C, and the answer is 1.31. Then sine theta C is equal to the inverse of N. So it's equal 1 over 1.31, which is equal to 0.763. Then theta C is equal to 49.73. The final problem is problem number 6. Light falls from air on a transparent medium of 1.5 absolute index of refraction and at angle of 30 degrees. Find the refraction angle. B. wavelength of light rays in the transparent medium. If it is wavelength in the air was 600 nanometer. The solution of A to find the refracting angle, we use Snell's law. N1 sine theta 1 equal N2 sine theta 2. 1 times sine theta 3, 1 times sine theta 3 equals 1.5 sine theta 2. We can simply find sine theta 2 is 0.333 and theta 2 is 19.45 degrees. The solution of B to find the wavelength in the transparent medium, we can use this relation. We have two ways. This is the first way. N2 over N1 equal lambda 1 over lambda 2. 1.5 over 1 equals 600 over lambda 2. Then lambda 2 is equal to 400 nanometer. Or we can use this relation. Sine theta 1 over sine theta 2 equal lambda 1 over lambda 2. So sine theta 1 is 0.5. Sine theta 2 is 0.333. Is equal to lambda 1, which is 600, and lambda 2 is unknown. Then lambda 2 equal to 400 nanometer. Thank you for listening and goodbye.